This will be the Nginx crash course that will clear all your doubts about Nginx and teach you all the important fundamentals in a very easy way. First, we will understand what is Nginx actually used for and what are its main use cases to understand why it was created in the first place. Then we'll jump right into the hands-on demo where we will take a simple Node.js application that just serves an index.html file and start 3 instances of the application as Docker containers on our local computer. And we will actually write the code and all its configuration ourselves. So you aren't just copy pasting some code, but really understanding every step and every single piece of configuration for a proper knowledge, not just shallow surface level knowledge. Then once we have multiple instances of our Dockerized application running, we will install Nginx and configure it as a reverse proxy to load balance requests to our application instances. In this context, we will learn how Nginx configuration works and how to work with Nginx in general. Last but not least, we will configure secure HTTPS connection to our application via Nginx proxy by enabling SSL and configuring Nginx with our self-signed TLS certificate. And in case you've never done something like this before, as I said, I explain everything step by step so you will understand every single detail of the configuration. Now, talking about simplifying complex things. At this point, probably every engineer already has heard of DevOps, which is an exciting but often scary field for many people. And you, as many other engineers, may be convinced already that learning DevOps will make you more valuable and will future-proof your engineering career. However, if you have dived a little bit into DevOps, you probably had a hard time understanding the big picture of DevOps. You probably saw all these technologies that DevOps includes, like containers and Kubernetes, Jenkins, and so on, and the complexity of combining all these technologies. And it makes it very overwhelming and hard for people to learn DevOps without a proper guidance and a roadmap. And that's exactly why back then we created a complete DevOps educational program that fully breaks down this complexity for you, where I literally take you through building the advanced and complex end-to-end DevOps processes. Not just some basic stuff, but actual real-life projects that actual experienced DevOps engineers build at work. And I take you through them step by step with the most understandable explanations without any tech jargon, and actually give you the in-depth, confident DevOps knowledge with no knowledge gaps. As we have done for thousands of engineers already, who many of them we successfully helped make giant leaps in their careers. So if you want to be one of those highly skilled engineers like our DevOps bootcamp students, instead of competing against them in the tech job market, then you can check out all the information about our DevOps bootcamp in the video description. And you can also download the entire roadmap or curriculum for free on the website if you want to familiarize yourself with it first. And with that, let's dive in to teach you how to configure and secure an Nginx reverse proxy for a web application. So let's get started. Back in the day, when the web was still simple with less users, the basic use case was a browser requested a web page from one web server. The web server was a server machine that had a software installed on it that assembled the page and sent it back to the browser, which then displayed it to the user. A piece of software that runs on a server machine and can respond to requests from a browser. And that web server software, that was Nginx, a piece of software that runs on a server machine and can respond to requests from a browser. Then web became popular, so you had thousands or millions of requests per website. Imagine one single server handling millions of requests. That's way over the technical limit of a server software. Well, we need a few more servers to handle that load. So we added 10 Nginx web servers. But now we need something that determines where requests from the browser end, which one of those 10 servers will handle them. And that's where load balancing comes in. So the same Nginx web server becomes a load balancer that proxies the requests to those 10 web servers. And by the way, the word proxy means to do something on someone else's behalf. So it accepts the browser requests on behalf of the web servers. So it sits at the entry like a concierge and then distributes the load among the web servers. Now, how does it distribute the load? That depends on whichever algorithm was configured on it. It could be a simple logic, such as just whichever server is least busy gets the request, or it could be a round robin, which is a popular algorithm that basically distributes the requests equally in a cyclical manner. So very simple load balancing logic. So now we have Nginx as web server software and the proxy as well. And that load balancing is just one of the functionalities of Nginx proxy. So it's the same server and technology, but with a different task now. So what are those other features or functionalities of a proxy? Imagine New York Times article comes out and millions of people open it on their laptops in the browser. Now imagine every time the request landed with one of the web servers that assembled the response, like put the images together, get them from a database, put text and paragraphs and everything together, edit all the links, sent it back as a response. And this happened a million times. Pretty inefficient, right? Instead, it makes sense to assemble this article, get all the data from a database, put the text and links and everything together once and store it. It's a static article. It's not going to change, right? So just keep one final copy and send it to everyone who requests it. That's caching functionality. And it is another main feature of Nginx proxy server. So you can configure caching on Nginx proxy so you don't have to hit the database or the web servers every time a request comes in. It will just return that cached file. Now imagine we have 100 servers of an online banking application or a social network like Facebook. That makes those servers a pretty juicy target for hackers. They all want to hack into your servers and get the treasure, which is payment data, personal data, passwords, and so on. Now imagine you exposed all 100 servers to public access. So basically all those requests can directly hit each of the web servers. If you do that, you actually make work for hackers so much easier. They would need to find just one issue in one of those 100 servers, and they could potentially break into your entire system. Because all your servers are publicly accessible directly, they can just ping the hell out of them and probe them until they find an issue or an entry because you forgot to update a library or a software package, and they can hack your web server application. So you have to worry about absolutely perfectly securing 100 servers. Now instead, we just give them one server that is the only one that's publicly accessible. You can put all your tightest security efforts on one server instead of 100 servers. And this way, having one entry point, which is the proxy, as publicly accessible entry point reduces the security attack surface tremendously and basically acts like a shield or security layer before all those web servers. So in addition to load balancing and caching, a very, very important functionality of a proxy is an added security for your web servers. Now, talking about security, I mentioned that since we have one entry point, we can focus all our efforts to securing that one proxy server in all aspects. And one important security measure is encrypted communication. So frontend will send encrypted message to the proxy, which means even if an attacker sees that traffic on user's browser or during the transmission, they can't read it. Only the proxy server can decrypt it. But again, for added security, in many systems, proxy that acts as a shield, a security shield, will simply pass on that encrypted message to the web servers, and the web server will decrypt it itself, which is actually a better security practice. So here, the functionality of a proxy is to be able to accept encrypted traffic with SSL encryption. So you can configure your proxy to deny any request that is not encrypted and only accept encrypted requests. Now imagine Netflix, which, by the way, uses Nginx in its backend. And as we know, Netflix has millions of users, so it's getting millions of requests for videos on its web servers. And let's say it's an evening in New York, millions of people come home after work, all at the same time. They switch on Netflix and start watching the most popular series at that time. That means suddenly at the very same time, millions of requests for a high quality video is sent to Netflix. So in this case, imagine that Nginx proxy server would have to send back the entire high quality video to millions of users at once. That's a lot of bandwidth. Imagine how long it would take to send it over the internet cables all the way to the TVs of millions of viewers. That's where compression helps. Nginx proxy can also be configured to compress large images or video files to save bandwidth both on the side of the clients, so people who are receiving those large files, but also on the server side, who is sending all that content. So it arrives faster and it uses up less of your internet bandwidth. And as part of it, it also supports sending responses in chunks instead of the entire file at once. So basically, it sends you part of the video, and then by the time you have watched the first half, the second half of the video has been sent over to you as well. So these are all the functionalities that you can configure for Nginx as a proxy server. Now, you may be thinking, how do you make Nginx do all these things? How do you configure them? How do you tell Nginx whether it should act as a web server or a proxy server? And how do you configure all this caching and SSL traffic and all this stuff? Well, that's where Nginx configuration file comes in, which lets you define all this configuration with so-called directives. This is where you can define whether you want your Nginx to be a web server or a proxy server, simply by configuring whether it should forward the traffic to other web servers or whether it should handle it itself. You can configure which port you want Nginx server to listen on. This is an example of a simple web server configuration that listens on port 80 and with location basically defines from where in the file system it should serve those static files back to the browser. But as we learned, communicating on port 80 or HTTP port is insecure. Instead, we want to encrypt all the communication. And you can configure that easily in Nginx to route any traffic coming on port 80 to HTTPS by sending those requests to HTTPS endpoint. And here we have an HTTPS server configured that serves the files as well as specifies the SSL certificate location, the public key and the private key for the SSL communication. And it listens on the HTTPS port 443. So that's a simple configuration that allows you to tweak Nginx to handle requests like that. You also have its own configuration to configure load balancing to multiple backend servers. And within that configuration, you can also define which load balancing algorithm to use, like select the least busy server or use the default one, which is round robin, which, as I said, just equally distributes the load in a cyclical order between those servers. You also have the caching configuration with multiple different elements, like how long the cache should be stored before it's refreshed and so on. And as you see, the configuration of all these functionalities is pretty straightforward, and it's also pretty granular. Like you can do tons of different configuration with Nginx, and you actually have a full list of all those configuration blocks and directives in this list here, which is a pretty huge list. And as you see, the configurations for proxy functionalities have proxy prefix, so you can differentiate them as well. Now, Nginx is very flexible, as you see, and super fast as well. So it became very popular in containers as well, and made its way as one of the most popular solutions for Kubernetes Ingress controller functionality. Ingress controller is essentially a proxy with advanced load balancing functionality, but for Kubernetes. So what Nginx was doing for simple web servers, it's now doing for Kubernetes cluster in the form of Ingress controller, acting as a proxy and load balancer that receives the incoming traffic first, and then based on the configuration that we define, forwards it to the right service inside the cluster. Now, this load balancing configuration, as well as the logic, is more advanced and more Kubernetes specific, but the idea is pretty much the same. And I actually have full videos on Ingress and Ingress controller and how to configure it. You can watch on my channel. In fact, I create these tutorials regularly on a lot of interesting technologies. So if you want to educate yourself in tech, make sure to subscribe and activate notification to get those new tutorial videos. Now, there are actually many Ingress controller implementations out there for Kubernetes, but Nginx is one of the most popular ones. And I have actually used Nginx Ingress controller in most of my projects as well. Now, some of you may be thinking, doesn't each cloud platform have its own load balancer? Why do I need Nginx as a load balancer? Well, you actually need both. Nginx Ingress controller, which acts as a load balancer, is used inside the cluster. So unlike the proxy for web servers, it's not publicly accessible, so you can't access the Nginx Ingress controller directly from the browser. It actually lives inside the cluster network and forwards the requests internally. So who is getting the requests from public? What is the public entry point for the browser requests? That's the cloud load balancer, like AWS ELB, for example, which then forwards that request to the Ingress controller inside the cluster. And this is important because it adds a very important security layer to those requests. So the cluster component is never directly exposed to public access. Instead, every request comes from the cloud load balancer, which then forwards it to the Ingress controller within the cluster, which then routes the traffic based on intelligent logic to different applications within the cluster. And with intelligent routing, what I mean is if you have one large application with lots of sub-segments or microservices, for example, you can configure your Ingress controller so if the request URL includes online cart, it routes the traffic to online cart microservice. If it includes payment, it routes the traffic to payment service, and so on. Now, as I said, Ingress controller in Kubernetes environment is a bit more complex setup than web server environments with proxies. But since Kubernetes became so popular, you kind of can't really avoid it. But I know many engineers, especially software engineers, don't really like dealing with all the Kubernetes configuration files and dealing with Helm charts, etc. to install various services they need in the cluster. And that's where an abstraction of that complexity can be a great solution for engineers. And this is exactly what Pulumi, the sponsor of this Nginx crash course, actually offers. They have created a solution to allow engineers to use whatever programming language they are familiar with to provision and configure resources in Kubernetes. So you could set up and configure the whole Ingress controller configuration, for example, in the Kubernetes cluster without ever interacting with the underlying Kubernetes components, which I know a lot of engineers will be happy about, simply using your preferred programming language as an abstraction with Pulumi. So Pulumi hides all that complexity for you, which you can imagine makes engineers much more productive. So huge thanks to Pulumi for sponsoring us so we could create this valuable crash course for you. Now, some of you who've been in IT for a little longer may have worked with Apache Web Server. So what's the difference between Apache Web Server and Nginx Web Server? Well, not much actually. Nginx and Apache Web Servers do pretty much the same thing. Just like Nginx, Apache also used to be a basic web server, and then they extended its functionality as a proxy. And it has all these benefits and functionalities of a proxy that we discussed. Apache was actually already widely used when Nginx was created. And the major benefit of Nginx was that it was faster, more lightweight, and definitely had an advantage when it came to serving huge amounts of static files. Plus, as you saw, it has a pretty easy configuration as well. And Nginx also became more popular in the container world. So let's dive into our demo project. And we're starting with a very simple application, and we're going to build this up step by step. We have one static index.html file, which basically displays an example website with some sections in it, and it references a few images. So we have something pretty to look at on the UI, and those images are also in the project. So super simple. So let's actually open this index.html file and see how it looks like in the browser. And I'm in the Visual Studio Code, and here I can just click reveal in Finder, and if I double click or just paste in the absolute path of the index.html file and hit enter, that's our website. Those are the images that are being referenced. Obviously, it looks ugly, but we have something in the UI to display. And all of this is static because, as I said, we just have one simple index.html. And as you see, this is just served statically from the file location. That's it. That's what we're starting with. So now, as the first step, let's actually add a backend server to serve this index.html file to the browser instead of us having to open this like a static file, basically like this. So that's also very simple. We're gonna use Node.js and create a very simple server.js. And I'm gonna paste in the Node.js code with a very simple logic. It basically starts a backend server on whatever port we define here. So on port 3000, it's gonna start a server using Express.js module, which is basically a lightweight server module. And once the application starts, it will serve the index.html to the browser using this logic. So every time we access the application on this root path, basically, it's gonna send back the index.html file, very simple, and it's just gonna log out in the console here that the request has been served or replied to by the Node app. And we're also serving the images because this index.html references the images, so they also need to be sent to the browser or served just like the index.html file. So all these files, basically all these static files, are served from the backend server to the browser. That's what's happening here. Super simple. And as you see, we have two packages that we are using here. And that means we need to actually download those packages from internet to our local machine so we can start this application. And for that, I'm going to create a package.json file. And I'm going to paste it in as well. And you have all these metadata, like name, version, description. And these are the dependencies, those two packages that we need for the application. And now, in order to execute our application, we need Node.js installed locally, so we can execute this. And in order to download those packages, we need npm, which is Node's package manager tool. We can install both of them simply by installing Node, which is very easy. If we look for Node.js download, you can execute those commands, or you can even download a pre-built installer, again, for your operating system. I'm actually going to download this one to show how easy it is. Just double click, install. And now you should have Node available. There you go. So Node also installs npm, which is Node's package manager tool for downloading those dependencies that we define in package.json, managing those dependencies, and so on. So the first command is going to be npm install to install those two packages that we defined here. And there you go. Those packages have been downloaded. So now that we have installed those packages, we can execute node server.js, which will basically start this application and print out Node app is listening on port 3000. And now it waits for our request to serve index.html, which means if we go back to the browser, and now I'm going to do localhost 3000, that's the port that we defined here, we should see our page served by Node.js backend. And as you see, difference here, this is directly from the file, and this is from localhost. And whenever we refresh a page or visit a page, this logic gets executed, and you see that request served line is printed out in the console. Awesome. So this is just very super simple setup. Now we're gonna Dockerize this application and then put Nginx proxy in front of our Node.js application. So instead of the browser request going directly to the Express server on Node.js, it will first hit the Nginx server, and Nginx will then forward the request to Node.js. So let's stop our application. And as a first step, we're gonna Dockerize our application, and we're gonna start 3 instances of the same app. And if you don't know Docker or how to Dockerize application, it's actually very simple. I have a separate Docker crash course, and you can learn step by step in detail over there. So what we need to do to Dockerize an application is obviously a Docker file. And as the rest of our application code, this is also going to be very simple Dockerfile logic. And let's go through them one by one. We are basically using a Node image because it's a Node application, so it needs to have Node and NPM available, just like we install it on our local computer. The Docker container that starts this application should have Node and NPM. Then we basically create this /app folder and define it as a work directory, and then we copy these local files from our project into this folder inside the Docker container. And we basically copy the server.js because that's the backend logic that needs to be executed. Then we copy the index.html file into that work directory. We then copy images, the entire image folder, basically inside /app/images folder, because that's where index.html expects them to be. And then we also copy the package.json because that's where the dependencies are defined. Then we execute npm install to download those dependencies. We expose port 3000 inside the container. That's where our application will be accessible. And then we simply do the same as locally, just start the application by executing node server.js command. Super simple. And with this Docker file, we're gonna now build our Docker image. And again, I'm gonna need to start my Docker application. And once Docker is up and running, I can build an image based on this Docker file. So Docker build, let's call our image my app 1.0 and location of the Docker file, which is the current directory, and let's execute. And there you go. Our image was built, and you can also check that right here or with Docker images. There you go. So we have an image of our application that we can start multiple copies of or multiple containers from, which is what we're going to do. So we just built the image, but the application is not running as a container. So let's actually check that. So if I refresh, the site is not accessible because our Node app is not running locally. So we can start it now as a container instead of executing Node server.js on our computer. So I'm going to do docker run, and let's actually bind the port 3000 to 3000 inside container. And this is the image that we want to build the container from. Let's run. There you go, app listening on port 3000. And if I refresh, we have our application accessible again. Awesome. So now this is our container, and I'm going to stop it because, as I said, we want to start 3 instances of the same application instead of just having one. So again, nothing running. And in order to start multiple instances or multiple containers, we're going to use Docker Compose. So let's clean up all this, and I'm going to create Docker compose.yaml file. And I'm going to, again, paste the code, which is also a very simple configuration. So let's go through it. So we have 3 services defined here, and we call it app1, app2, app3. And this is going to be the same application in all 3 cases built from the same Docker file. So with Docker Compose, you can not only start existing images, but you can actually build an image from a project or from Docker file and then start those newly built images. So that's what we're doing here. We're building the image of app1 and we're starting it. We're building the same image of app2 and app3. And what we're doing is to differentiate between those replicas of the same application. We're just gonna pass this environment variable that basically says this is app1, or replica 1 of the application. This is replica 2. This is replica 3. And we can use this environment variable inside the application itself. So what we're going to do here is a very simple change. So basically, we're passing this environment variable to our application inside that Docker image that we're building. So this application will have access to this environment variable inside the logic. And we can access environment variables in Node.js using process.env. And whatever the name of the environment variable, which is app name. And this is going to be, we can save it, let's see, a replica app or something like this. So instead of node app, we can say, and again, this is Node.js syntax. And we're going to do string concatenation. So basically, we are saying this request is served by whichever application replica that is. And we're going to do the same right here. So in the logs, we will see which of the 3 replicas the request is handled by. So the application will run fine without this change, but we're just doing that as additional information for us in the logs to see and to compare which application replica is currently serving the request. Awesome. So that's prepared. And now when Docker Compose builds this application, it will grab the Docker file and it will basically copy all these files, including server.js, where we made those changes, and it will build a new image which contains this changed logic. And as we see here, it will read the value of the app name environment variable for each instance. So for this service, it's going to use app1 here. For app2 service, it's going to use app2 here, and so on. And then we have final configuration, which is port. And since we want to run all 3 replicas on the same machine, on our local host, the ports need to be different because we cannot run 2 applications on the same port, right? On the second time, it's going to say error, the port already in use. You can't do that. So the application inside the container itself is going to start on port 3000. That's what we're also defining here. And in Docker file as well. So this will stay the same, but on the local host, we're then binding that on port 3001, 2, and 3. That's how it's going to work. So again, this will start those 3 services with these 3 slightly different configurations. And now all we need to do is start Docker Compose to create and start those 3 Docker containers. And we can do that simply by executing Docker Compose up build. And we're going to start all the containers in the background. Let's hit enter. And there you go. Let's see the logs. As you see, it built the Docker images for app1, app2, app3. And then it started 3 containers in the background, which means if we do docker ps, we should have 3 containers all running the same application, but on 3 different ports, which means those 3 ports, 3001, 2, and 3, obviously nothing is running on 3000, but if we check 3001, there is our replica number 1, this is replica number 2, and then we have replica number 3 as well. And we can check the logs. And this is application 2. And we see request served by app2. And same with the other ones. This is number 3 and so on. Awesome. So now the final part that is missing is we don't want to have to access each replica separately one by one. We want to have one entry point that then automatically forwards the requests to one of those 3 replicas. And that entry point is going to be Nginx. So we're going to now install and configure Nginx proxy and put it in front of those 3 application instances to load balance requests to them. Plus, we also want to configure a secure connection to our application. So instead of HTTP access that we're using right now, we want to be able to access our application using HTTPS endpoint. which we will also configure on Nginx. So Nginx basically will act as a load balancer and as a proxy that secures the access and does all sorts of other configuration before the request even reaches the backend server. And in order to configure Nginx, obviously we need to install Nginx locally first, which is also pretty simple. On macOS, it's simply brew install Nginx. Let's execute. So the installation is done. Now we can check if we have Nginx successfully installed, and there you go. We have this version of Nginx locally available now. And with Nginx installation, obviously comes a bunch of configuration of Nginx that we need to do all sorts of things with Nginx, configure it to our needs, because as you learned, Nginx is a web server, it's also a proxy, and you can do lots of types of configuration for proxy as well as web server to change the behavior of Nginx. And to find the installation location of Nginx, we can execute where is Nginx command. And this basically shows you where it was installed. That's the location. Or we can also execute Nginx V, which will show us a bit more information about Nginx configuration itself, including where the configuration file is located. So I'm going to search for Nginx conf, and it's in the installation logs, as well as right here. So this basically shows us the location of the Nginx configuration file. That's what we need in order to tweak the configuration and behavior of Nginx. So if I copy this entire path and print out the contents of Nginx conf, you see all this configuration logic. And as you see, most of it is actually commented out, but we can also see that readability is much more difficult than in an editor. Plus, if we want to work with this file and make changes, I personally wouldn't prefer to do it with a Vim editor in the terminal. So what we can do instead, we can open this file inside a Visual Studio Code. And an easy way to do that is, let's go back to our VSC. And in the command palette, which is Command-Shift-P, I'm going to type in shell command install code in path. So this is an option basically that makes this code command available inside the terminal to open any files with Visual Studio Code. So I'm going to click on it. Let's do OK. Provide password, because this is making change to the path in the terminal. And now if I go back, instead of using Vim here, for example, as an editor, we can just do code. And let's see. There you go. It just opened the configuration file for Nginx inside editor. And now we can see it much better. Those green lines are basically just comments. So we have a lot of boilerplate configuration that Nginx installs with, but we actually don't need any of this. We're going to start from a clean state. So let's remove it. A note here is that even though we have this file open inside our editor in a project, obviously it doesn't belong to our project. It's living in a completely different path location, which is this one right here versus all these files who live directly in the project. So in VSC, and I believe in all the other editors or IDEs, you can basically open files from different locations in the same editor, which is very convenient. And if I click here, reveal in Finder, you will see the actual location on your file system. And you can also see the entire hierarchy. So you have etc, Nginx, and that's our configuration file. So now we can actually configure our Nginx installation to become a proxy of the 3 container applications that we have running locally and load balance requests to them. So starting with a clean state, let's actually start writing the Nginx application line by line and also explaining what each one of those configurations actually mean. So we start with the first one, which is worker processes. So what's that configuration? This is basically a directive. In Nginx, all these key value configurations are called directives. And the worker processes directive basically sets the number of worker processes that Nginx should start with. And worker processes are the ones that are actually doing the work of getting and processing the requests coming from the browser, from clients, and so on. And the number of worker processes will directly affect how well Nginx can handle high load of requests. So the more worker processes we have, obviously, the more requests Nginx can handle. And for the demonstration, we're starting with just one worker process. In production, however, it's generally recommended to set the worker processes value to be equal to the number of CPU cores that is available on the server where Nginx is running. So that means if you have multiple CPU cores on the server, you can start that many worker processes to take advantage of the parallel processing and again, to handle the request much faster. And we can also define the value to be auto, where Nginx will basically intelligently decide based on the underlying infrastructure how many worker processes it should start with. We're gonna again set it to 1. And next, we're gonna configure the way connections will be handled by Nginx. So basically, per worker process, we're gonna define how many simultaneous connections each worker process can and should handle. And for that, there's configuration called events. And inside, we have worker connections. And we'll set the value 1024 here, which basically means that for this one worker process that we have, it will handle 1024 simultaneous connections. And as you can imagine, the higher the value, the more requests each worker process can handle. But the downside is that it also increases memory usage because you have multiple connections open at the same time that your worker processes are handling. So you kind of need that fine balance between those, depending on the resources that you have on the server. So these are kind of like a meta configuration of Nginx in terms of when it starts, how performant it should be. And now we're going to get to the core of Nginx configuration, which is the actual logic of how the traffic will be handled from client, what Nginx will do with it, and so on. And all that logic goes into a block called HTTP. That's basically our main configuration. And this is where we define how to handle HTTP requests with Nginx. And inside HTTP, we have the main configuration for the Nginx server, which defines where is Nginx listening, on which port, where is it available to accept the requests, and then what does it do with those requests. So that is a server block. And here we have the port. So we're going to set Nginx to listen on port 8080, which is a standard port for local development or testing. And the server name, which is the actual domain or IP address of the request. So basically, where is the client sending those requests to? Like facebook.com, example.com, and so on. In our case, it's going to be localhost. And then we have the location, which is the URL that client requests. So basically, whenever someone accesses localhost on port 8080 on this path, which is just the root path, basically, what do we do with that request? How does Nginx handle that? And that's where the logic is going to be. And as I said, we want Nginx to accept those requests and then forward it to those 3 application replicas we have running, which means we are setting up and configuring Nginx as a proxy for those backend Node.js applications. And that means we're going to tell Nginx to pass or forward the requests to those backends. And the configuration for that is proxy pass. So we are explicitly configuring our Nginx to be a proxy server, and we're telling it to send or pass the traffic to the Node.js applications. Now, those backend applications that Nginx forwards the traffic to are called upstream in Nginx configuration. So we're going to define an upstream in Nginx configuration, and the proxy pass basically forwards to that upstream. And we have to define that upstream as a separate configuration right here, like this. And we're gonna give that upstream some kind of name. And let's actually call this Node.js cluster. And this is a very simple configuration. We're gonna basically list all the backends or all the servers that Node.js should forward to or use as upstream. So we're gonna have server, and let's do docker ps again. And as a reminder, our applications are running on localhost, which is local address 127.0.0.1 on these 3 ports, right? So the first one is port 3001. That's our first server. Then we have a second one running on port 3002 and then 3003. So these are our 3 servers, which will be the upstream of Nginx. And right here, we can reference that upstream using its name that we defined here. And we can add a protocol here, HTTP, and the name of the upstream. So again, we are explicitly configuring Nginx to act as a reverse proxy, basically a proxy that is sitting on the side of a server as an entry point of all the client requests, and then load balances or forwards them to the backend servers, and then passes the response from the backend servers back to the clients. Then we have a couple of more important configurations of a proxy. The first one is when Nginx gets a request from the client, we want Nginx to actually forward the requested URL, whatever URL the client actually requested, to the backend servers. So the Node.js applications or the backend applications can actually see the original request from the client, like which domain, which subdomain, which URL path was requested, and so on. And this is important so that backend applications can use that logic to do proper routing. So right here, for example, depending on what URL was requested exactly, it can execute the right handler for that specific URL. And that's why it's important for Nginx to send the original URL that client requested to our backend servers, because they need this information as well. And the configuration for that is proxy set header host. So that's the host that is requested by client. Nginx has that value stored in this variable. So whatever that value is, we are setting that right here to be forwarded to the backend applications. And this probably looks familiar if you know HTTP headers. So in the proxy forward request, we can actually set a bunch of headers in that request of the proxy that include important, valuable information for our backend application. Because backend does not interact with the client directly, it gets all the requests from Nginx, right? Nginx kind of acts as a shield and as the first entry point. So backend will only see whatever Nginx forwards it. It will never be in direct contact with the client. So it's important that Nginx actually sends any important information from the client without hiding them or missing them to the backend, as we're doing here. And another mostly very important piece of information is the actual client IP address that made that request. And again, by default, when Nginx forwards the request, the backend application will just see the IP address of Nginx. But we can tell Nginx to also pass the original or real IP address of the client. And it's stored in a variable called remote address. That's where Nginx has this information. So it will just pass that on to the backend application. And again, this is important for logging purposes, where backend needs to know the actual IP address of the client, for security purposes, analytics, to see exactly which client request was handled by which application, and so on. So this is also a pretty important piece of information. And that's basically our whole configuration of the server and how to handle any server request. We can add 2 more optional configuration directives here. The first one is also a pretty widely used one, an important one in Nginx configuration, which is including the file types in the response to the client. So when Nginx returns the response from the backend application, whether it's an index of the HTML file or the images or maybe JavaScript and CSS files, it can include the type of the file in the response as well. And this is important so that browser or HTTP client that gets the request, it can basically see in the response header the type of the file, and it can help display that file or handle that file properly on the client side. And there is a very simple directive for that called include. And we basically say, please include the MIME type of the file that you are sending back. And Nginx actually has a list of MIME types that it can reference that comes when we install Nginx. So it can include those, as I said, in the response header when it sends it back to the client. And another optional configuration is right here, we're defining the servers that Nginx will load balance to, right? So it will forward the request to these servers. And we can define a logic of how Nginx decides which server to forward the request to. Because we have 3 of them, right? How does Nginx know? Does it forward the request to server 1, server 2, server 3? And that logic is defined by an algorithm, a load balancing algorithm. By default, this will use an algorithm called round robin, which basically means it will forward the first request to this one, the second one to this one, third one to this, and the fourth one to the first again, and so on. So basically forwards the request to each one in a cyclical order. And we can override that algorithm if we want to. Let's say we know that our server 1 or wherever this is running, for example, or this application instance has much more resources, so it can handle much more volume or number of requests. And this one has the least one. So we don't want to evenly distribute the requests. Maybe we want the one that's the least busy to always get the requests. So we can override that configuration by defining an algorithm here for least busy, or the one with least connections is this configuration. So instead of round robin, Nginx will forward the request to whichever server has the least connections. So that's our whole configuration. And as I mentioned, those key value pairs that we have configured are called directives in Nginx. And those enclosing blocks like events, HTTP, and so on are called context. So within events context, we have this worker connections directive. These are the specific terms that Nginx uses for the configuration. And with that, we actually have our ready Nginx configuration that we can use to start our Nginx server, and it will start forwarding the requests to our Docker container instances. So let's test it out. Let's go back to the terminal, because even though we installed Nginx, it's not actually running. And since we have a new configuration here, we can start Nginx with this configuration. So as soon as we save it here, obviously it gets updated. So to run Nginx, we simply execute Nginx command, and obviously it doesn't say anything. So if we want to check the logs, let's bring up that verbose output of Nginx configuration, and let's look for where the log file is located. This is the error log, and this is just a simple log. So let's copy that, and it's empty for now. So now let's go and access our Nginx application on port 8080, because that's what we defined, right? So we have this server that's listening on localhost port 8080. And if I hit enter, there you go. Nginx just served our application. And again, let's check the logs. And now we have a bunch of stuff here. So we are accessing localhost 8080, which is the location where Nginx proxy server is listening. And as soon as it gets the request, it uses this configuration to decide, okay, that's where I need to forward this request to. And it basically chooses, based on this algorithm logic here, chooses which application instance it should forward that request to, and that application that returns the index.html file as it's supposed to, and Nginx will then send that back to the client. And let's do one more thing to actually see exactly which of these instances is always getting the request from Nginx. And right now, all those 3 instances are running. So what I'm going to do is I'm going to stop those. So let's do docker compose down. So it's going to stop and remove those containers. And let's check that Nginx is not able to deliver our message. And as you see, we are still hitting Nginx endpoint, but Nginx itself is sending us a request saying, I received your request, dear browser, but my backend servers are not responsive, which is this 502 response here. So whenever an HTTP code starts with 5, it is some kind of issue on the server side. So it basically says my servers have some issues. I cannot fulfill your request right now. And it just shows Nginx version. So now I'm going to start the Docker Compose up, but we will see all the logs directly in the terminal when the containers start like this. So all these 3 apps are listening. Let's refresh. And there you go. The request was served by app 3 and app 2. Let's refresh again. And let's check one more thing. So this is the Nginx location. And if I open the developer tools in network configuration, let's refresh this again. And we see this is a localhost 8080 request. Let's actually empty the cache and refresh again. There you go. And right here we see server Nginx with the version powered by Express.js. So we see that the request is being handled by Nginx. And this one is addressed where one of the Docker containers is accessible directly. And here, let's refresh again, empty the cache. And here we just see Express, which is directly serving the requests, but there is no server configured here. And you may be wondering here, when we have Nginx as an entry point, should we have the individual backend servers also directly available? In practice, it should not be the case. This only works because we are on localhost, but Nginx is a server, right? It's a proxy server. So it usually is installed on a server, usually on Linux server where the application is running. And on that server, you will simply open port 8080 where the application or Nginx server will be accessible. And all other ports on the server, including where the backend applications are running, will not be publicly accessible. Only internally for Nginx to route traffic to them. So as I said, in real life scenario on a server, which is accessible on a domain address like techworldwithnana.com, for example, you will have the port open where Nginx is running, and all the actual backend servers will never be exposed directly to client requests. That's how it should work. They should only be accessible by Nginx itself. Because, as I said, this is more secure. We only want to have one entry point, so we minimize the attack surface of our application. Now, talking about security, let's actually configure a secure configuration of our application via Nginx. So instead of HTTP request, we want clients to send HTTPS requests to our server. We only want to allow secure SSL protocol requests because with HTTPS, the data is encrypted. So request and response can be exchanged between client and server much more securely, even if someone is sniffing the traffic and basically sitting in the middle and interfering with that traffic. So we want the encrypted traffic, which is kind of a default and pretty much a standard nowadays. And that's what we want to configure with our Nginx. And if you've never worked with Nginx before, if you've never created certificates and never configured anything for secure HTTPS connection, this configuration is actually much easier than you may think. So let's do that as our last step. So in the last part, let's configure secure SSL access to our application. So going back to our terminal, in order to enable HTTPS, we need what's called an SSL certificate. So the certificate basically validates the server and also contains a public key or public certificate that client can use to talk to the server. And we can actually generate an SSL certificate locally on our machine, and we can generate what's called a self-signed certificate. So we're generating the certificate and we are signing it ourselves, saying we approve that the certificate is valid. Again, usually in production, actual environment, the certificates that you generate for your server, for your backend, is signed by an actual official authority for SSL certificates. So they basically give a stamp on your certificate saying, we, an official authority, and there's an actual list of them, we validate that this server is legit. And then client, when they see the certificate signed by that official authority, they're like, okay, got it. We trust that this is a valid server certificate. We're talking to a valid server. Now, if this entire concept is completely foreign and completely new to you, I actually cover this concept in detail in our IT fundamentals course, which covers the entire software development lifecycle, including the client-server requests and so on. And we decided to temporarily make this specific lecture available for our viewers so you can learn that concept in full detail to understand it much better. We're going to make it available temporarily for public, so make sure to check it out. And as I said, generating a self-signed certificate is actually pretty easy. We have a service or a command line tool actually called OpenSSL, which lets us do it with just one single command. So first, let's actually create a folder where we're gonna put those certificates that we generate. So I'm gonna create this folder in my home directory, and let's call it Nginx certs. Let's change into that directory. And as I said, with a single command of OpenSSL, we're gonna generate our certificates. And I'm gonna paste in the command and explain all the parts. So this is the certificate type that we're generating. This is a standard certificate format, basically. We're generating a certificate that's valid for 365 days. So after that, certificate will not be valid anymore. So we would need to create a new one and configure Nginx with that new one. And these two options are the most important ones that basically define location or where to save the two files that this command generates. So SSL certificate is basically a key pair. So we have two keys. We have the private key and we have the certificate that holds the public key. As I said, private key is for the server. So this is staying on the server privately. Nobody should see this. And the public key is the part that is sent to all the clients that includes the server information. That's why it's called public. So those two files will be generated and saved with these names. And obviously you can call the file whatever you want. So this is key out location and this is public key location. And let's execute this. And it will ask for a couple of information for your server, for your application. So it's asking for a country code. I'm gonna do the 2-letter country code. So US or Austria in my case. TechWorld with Nana, that's the company. You can leave some of those empty. And now, if I do ls, I should see those two files generated and saved in this folder. Again, this is the private key with .key extension, and this is the public key or certificate file that holds that public key. You can even check the contents of how that actually looks like. And that's basically the format that we generated. This is the RSA 2048-bit format, and that's how it looks like. So we have our self-signed certificate or key value pair of our certificate, which means now we can configure Nginx to use those certificates in order to secure connection with our application. And configuring Nginx with SSL certificate is also pretty easy. Let's go back to the Nginx configuration. And right here in this server context, we're going to make a change and we're going to say Nginx will listen not on port 8080, but rather on a HTTPS port. So if we're connecting to HTTPS endpoint, the default port for HTTPS is 443. So that's where Nginx will listen, and that connection will be secured with SSL. All of this will stay the same. However, we need to define configuration for this SSL secure connection. So basically, we're gonna tell Nginx use these certificates or this key pair as public and private key. So basically, after we have enabled SSL, we're gonna configure the certificates for that SSL connection. And we have those two directives, SSL certificate and SSL certificate key. So this is the public key or certificate, and this is the private key. And we simply need the location of the certificates, and let's grab them. So that's the public certificate, and then we have the private key, and that's it. So we're telling Nginx this is a location of the public and private key files, and use them to configure the SSL connection. And this is our configuration, as simple as that. And let's not forget to add colons here at the end of directives. And now, this is an important concept here. We just made a configuration change of Nginx config, right? So the Nginx that is running already, it basically has the older configuration that it loaded when we started Nginx service. So when we change the configuration, we need to reload or restart Nginx so that it can load the new configuration and use that new configuration when it starts up. And going back to terminal, let's do help. And here you see a bunch of Nginx subcommands. And one of them is this one here, signal. So basically sends signal to the main process of Nginx, whether to start Nginx process, to quit, reload, reopen, and so on. So we need to reload our Nginx like this. So now if I try to access a local host on port 443, that's what we configured, and HTTPS, that's the port with HTTPS, and let's load. And there you go. First of all, we see that a certificate is configured. It's just telling us that the certificate is not valid because we generated a self-signed certificate. As I said, in practice, you have certificate authorities who sign those certificates, and that's how browser knows it's a valid one. For self-signed ones, it doesn't know. But we know that it's our certificate. We're just on localhost testing this, but it means that certificate was loaded, and now we can just do advanced and proceed to localhost, and there you go. So now you see this HTTPS in the URL and localhost without 443 because that's the default. So we don't need to pass that port explicitly. And if we look at the network again, let's reload. As you see, here's a HTTPS connection on port 443. Again, served by Nginx. Okay, now let's see what happens if we try to access localhost 8080 again. And as you see, this HTTP endpoint is not available anymore. However, we can do one more configuration here, which is if the users or clients try to access our application on HTTP endpoint, then we automatically forward them to the secure endpoint. So even if they don't type in HTTPS/localhost, they will still be forwarded to that HTTPS endpoint. And we can easily configure that right here by defining another server. And we can say listen 8080 as we had before. The server name is localhost. So basically the same configuration as before, which means Nginx will listen on this port, but also on port 8080. But in this case, we define a different logic of how to handle requests that come to this endpoint, location. And we simply say, whenever someone requests URL at this endpoint, simply forward them or redirect them to this server. So we return 301, which is a redirection HTTP response. So we're basically saying nothing is available on this address. You will be redirected to HTTPS whatever host you requested and request URI. So basically, we are redirecting that request to the HTTPS endpoint of this request. And again, let's reload Nginx. And now, if I refresh, as you see, we can try it again. I'm requesting localhost 8080, which automatically redirects me on this HTTPS endpoint. And by the way, a default port for HTTP endpoints is actually port 80. So we could also change this to port 80 instead of 8080. And if I reload and just do localhost without a port, because 80 is the default on localhost, it will redirect directly to HTTPS localhost. So that's our configuration. And that's how you can use Nginx as a proxy or reverse proxy server for your backend applications, no matter which programming language or tech stack these backend applications are built in. And to clean up all the resources, we can go back and stop Nginx. We can check whether any Nginx processes are running. There you go. Nothing's available here. And we can also stop our Docker containers so that nothing's running anymore in the background. So that was our simple but very powerful configuration of Nginx. I hope I made the demo easy to follow as well as informative for you so you could practice along and learn a bunch of new concepts. If you found this tutorial useful, make sure to share it with one colleague or friend of yours who you think will also benefit from this knowledge. As always, thanks for watching and see you in the next video.